Hello, my name is Jim Kelly, and this video is about big numbers. I'm going to show you how big numbers can come out of a modest proposition. I think the results will surprise you. I call this problem the chessboard problem. And what we have here is a chessboard, and we put 1 penny on the first square, 2 pennies on the second square, 4 pennies on the third square, 8 pennies on the fourth, 16 on the fifth, etc., until the board is filled up. The question is, how much money would that take to fill the board? Let's use a little mathematics to solve this problem. So, on the first square, we have 1 penny. On the second square, we have 2 pennies. On the third square, we got 4. On the fourth square, we got 8. On the fifth square, we got 16, etc. And the way mathematicians would represent this is, we'll call that one 1, and then we're going to add a 2, and then we're going to add 2 squared. That just means 2 times 2, which is 4. Then we're going to add 2 cubed, which means 2 times 2 times 2. And then this is going to be 2 to the 4th. And that gets easier when you get down, especially to this last square, 64th square. If you look at it, the third square has 2 as a power here. The fourth square has 3 as a power. The fifth square has 4 as a power. So the power is always 1 less than the square number. This is 64th square, so the number of pennies on that one are going to be 2 to the 63rd. So, the sum of everything we're going to call S, an unknown number that we don't know yet, so we call it S, the sum, and that's going to equal 1 plus 2 plus 2 squared plus 2 cubed plus 2 to the 4th plus, and then because mathematicians are lazy, they don't want to write everything out, they put dot, 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 meaning do the same thing until the final one, which is 2 to the 63rd. So if we could add those numbers up, we'd have the total number of pennies to cover the board. And using a trick, we can add them up. And the trick is to multiply both sides of this equation. Since this is equal to this, if you do something to this side and you do it to that side, the equation is still going to be true. So I'm going to multiply by this number 2 that we've been dealing with, and I get 2s is equal to 2 plus, because 2 times 1 is 2, 2 times 2 is 2 squared, 2 times 2 times 2 is 2 cubed, plus dot, 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 plus 2 times 2 to the 63rd is 2 to the 64th. Now we got 2 equations. And what I'm going to do is I'm going to subtract this equation from this equation. So I would have 2s minus s is just s is equal to all of these numbers minus all of these numbers. But notice these are the same and most of the numbers are the same. So when I'm subtracting, they're going to go to 0. 2 minus 2 is 0. 2 squared minus 2 squared is 0. So this equation, the only thing that's left is this number and this number, because the 2 to the 63rd canceled out with this one. So I get S equals, that one's left and that one's left, and we're taking this equation and subtracting this equation. So it leaves 2 to the 64 minus 1. And that's our answer, but now we gotta make sense of what that means. So we're gonna calculate 2 to the 64th power minus 1. And I'm gonna use an iPhone calculator here to do that. And I'm gonna use this function right here, x to the y. So I just enter 2, x to the y, and then 64, and equals. And there it is. There's our answer, and then we'll subtract 1 from that. But it's 1.84467440737 times 10 to the 19th power. So to sum up our little problem here, the number of pennies to cover the chessboard is 1.844, etc., times 10 to the 19th, or this number right here, 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 700 million pennies, or $184 quadrillion worth of pennies. That's 4,000 times the amount of money in the entire world at this time. So I hope that surprised you. It certainly surprised me when I first saw it. Thank you very much.